Hello beautiful people and welcome. Per request, I am making this video for your Chapter 8 practice test. This will include your time sections and your non-calculator with a calculator sections. Let's go ahead and start. This section is going to be 20 questions in under 10 minutes. This is a timed section. Now, I am going to walk you through some of them and then I'm just going to write down the answers. For tangent of negative 240, the way that you are expected to do this is you're supposed to figure out what quadrant this angle is in, then tell me the answer for tangent, sine, secant, cosecant of the reference angle. So for us, if I was to quickly draw this out, we are going towards the negative direction. This is negative 180 degrees. This is 270 degrees. So I don't have that. I have here an angle of negative 240 degrees. The reference angle is this angle right here, which is going to be, if we take a look at 40, 50, 60, 70, this is 30 degrees. So this reference angle is 60 degrees. So what I have here is quadrant 2, reference angle. And again, on the test, this is a memorization. This is a timed section, so you're not going to be writing anything like that. If you need to, go ahead. But the more you write, the more time it's going to take. Reference angle, so we want to find out what tangent of 60 degrees is. Tangent of 60 degrees is root 3. So in quadrant 2, tangent of negative 240 degrees is going to be all students take calculus. That means sine is the only function that's positive. That means tangent is going to be negative. So your answer is negative square root of 3. Moving on to number 2, sine of negative 5 pi 6. With radians, it's a little bit easier to find the reference angle because we just take a look at the denominator. The reference angle is going to be 1 pi 6. So we are taking a look at sine of pi 6. Sine of pi 6 is 1/2. Now we need to figure out what quadrant this is in. So 1 pi or 6 pi 6 would be half a cycle. Now I'm going down because we have a negative angle. So this would be 6 pi 6 at half of a cycle. We don't have half of a cycle, we have a little bit less. So I'm going to bring it back. This is our angle. We are in quadrant 3. All students take calculus. Only thing positive is tangent in quadrant 1, 2, 3. So that means sine of negative 5 pi 6 is a negative 1/2. And that's how you are expected to go through. Again, you should have these memorized. Cosecant is the reciprocal of sine, so we're technically looking at sine of negative 315. The trick here with anything ending in a 5 in your degrees, your reference angle is going to be a 45-degree angle. So we technically have sine of 45 degrees, which is square root of 2 over 2. Now we don't have 45 degrees, right? That's a reference angle. Instead, we have 315 negative. So we're going down. That's 270. We are in quadrant 1. So we have sine of negative 315 is root 2 over 2. But again, we are not asked for sine. We're asked for cosecant. So we're going to take the reciprocal of that. And so cosecant, see if I have space here, cosecant of negative 315 degrees is the square root of 2. Now how do I do that? Let me just do that off to the side since I'm lacking space. This should be memorization, so you shouldn't need to write any of this down. But we left off with sine of negative 315 degrees being a root 2 over 2. Since we are being asked for the reciprocal function, we are flipping our ratio, and we cannot have a denominator with the radical, so I'm going to multiply top and bottom by the square root of 2, which we have cosecant of negative 350 degrees as 2 times the square root of 2 divided by 2. Our 2 simplified cosecant of negative 315 degrees is the square root of 2. Okay, moving on, we have the next one, again, cosecant. I'll just do it this way. We're here. This is question number 4. Cosecant of negative 330 degrees. Again, you want to take a look at where that's at. We know this is going to be going down towards the negatives because we have a negative degree. We know a full cycle is 360 degrees, so we're going a little bit shy of that. That means our reference angle is 30 degrees. So we want reciprocal function sine of 30 degrees is 1/2. All students take calculus, so that means sine of negative 330 degrees is also 1/2. But they are asking us for cosecant. Cosecant is the reciprocal of sine. So cosecant of negative 330 degrees, we're flipping these to 2 over 1 or just 2. Question number 5 is asking you sine of negative 45 degrees. We're going down towards the negatives. Negative 45 is here, which the reference angle is also 45, so we have square root of 2 over 2. This is in quadrant 4. All students take calculus. Cosine is the only thing positive in quadrant 4, so we have a negative on that one. Not much to do there. Question number 6, tangent of 135. 135 is going to be here in quadrant 2. Again, anything ending with a 5 in degrees, so you're going to have a reference angle of 45. All students take calculus. That means tangent is going to be negative. So tangent of 135 degrees is negative sine, of 45 degrees. I don't know why I said sine. I apologize. Tangent. Tangent of 45 degrees is 1. So therefore, if we take our answer from our reference angle, write it down here, we have a negative 1 because it is in quadrant 2. 7. Question number 7 is asking for secant. All of these end up being negative. Not all of them, some of them. I thought I messed up, but I didn't. This is positive, so I went up to a positive y. That was good. 7 is secant of negative 30 degrees. Okay, negative 30 is here. We have a reference angle. This is quadrant 4. So again, reference angle of negative 30 is 30 degrees. So we're looking for the reciprocal of secant, which is cosine. So we're looking for cosine of 30 degrees. Cosine of 30 degrees we have as root 3 over 2. Since we are in quadrant 4, cosine of negative 30 degrees is all students take calculus. It is still positive, root 3 over 2. And then since we are asked for the reciprocal function, we're going to flip our fraction. So secant of negative 30 degrees is going to be positive 2 over root 3, and we have to rationalize the denominator, multiplying radical 3 top and bottom. That means secant of negative 30 degrees is 2 root 3 over 3 times 3 is 9, square root that is 3. And again, that's positive because in quadrant 4, cosine is positive. Question number 8. Question number 8 is sine of 4 pi thirds. And then as we know immediately the reference angle, because in radians we just look at the denominator, reference angle is going to be of 1 pi third. That means we are at a 60 degree here for our reference angle, because I'm thinking 3 and 6 have a relationship. 4 pi thirds, we are actually going to be in quadrant 3. And all students take calculus, so that means our answer is going to be negative. And so sine of pi thirds is going to be root 3 over 2. And since we are in quadrant 3 only tangent is positive, so that means sine of 4 pi thirds is going to be a negative root 3 over 2. So as you go through, again, in the beginning, draw these out, but over time, you are supposed to have these memorized. You might need to think a little bit about these. We left off at question number 8, so question number 9. Question number 9, we have 5 pi fourths, denominator 4. That means you're going to have a reference angle of pi fourths. Tangent of pi fourths is 1. Then you figure out which quadrant this is in. Quadrant this is in is quadrant 3, and so we have a positive. Tangent of 0, 0 is our initial ray, and our initial ray is at 0 for tangent of 0. Cotangent, the reciprocal of cotangent is tangent, so we're looking for tangent of pi thirds. Tangent of pi thirds is root 3. So if we have tangent of pi thirds is the square root of 3, we put a 1 underneath that, and then we flip it. So we have 1 over root 3. We need to rationalize that. So the reciprocal functions do require a little bit more work. So we have here of root 3 over 3. With cotangent and tangent of 60 and 30 degrees, pi sixths, pi thirds, you can also think about them having a relationship with each other. Tangent of pi sixths is root 3 over 3. Tangent of pi thirds is the square root of 3. So they do have a relationship. Once you flip it, they can be memorized that way. 12, tangent of negative pi sixths. Reference angle is pi 6, so we have root 3 over 3. Quadrant, we go backwards. We are in quadrant. I'm thinking about it. Oh, we're less. So we are in quadrant 3, so we are positive. Secant of 3 pi fourths, again, reciprocal function of that is cosine. Then we want to simplify that. 4 means we have a root, 4 means we have pi fourths of that. That means cosine of pi fourths is root 2 over 2. Take its reciprocal, we end up having root 2. 3 pi fourths is positive in quadrant 2, so that means all students take calculus. We do have a negative here. Cosecant of pi halves is 1. Tangent of 60 degrees is root 3. Cosecant of 90 is 1. Cotangent of negative 11 pi 6, that's almost a full cycle, root 3. Cosine of negative pi, so we're going down, we have negative 1. Sine of negative 7 pi, so almost a full cycle, going down, we are in quadrant 1. We have a root 2 over 2, again, denominator 4, that should tell you the reference angle. Cotangent, we want tangent. 3 tells you the reference angle. We are almost at a full cycle, almost at 6, but not quite. So we are a quadrant. And we have negative root 3 over 3. I did speed through the bottom ones because this is going to be a timed section. Moving on, you do need to know your unit circle, so I'm going to skip through that. We did practice that in class. And let's go ahead and start with the no calculator portion. No calculator portion, question number 1 is find the measure of each angle. So this is given to you in radians. And what they want is they want to know the distance of this full cycle here in pink with the quarter cycle here in yellow and the little tiny bit that they also give you as 5 pi 18ths. The easiest way to do this is to identify your full cycle, your half cycle, and your quarters. Your full in radians is your 2 pi. Your half in radians is pi, and your quarter in radians is pi halves. Convert that to common denominators. We have an 18, so I'm going to put a 1 underneath that, and so I'm going to multiply top and bottom by 9, top and bottom by 18. 18 times 2 is 36 pi, pi 18ths. Half is 18 pi 18ths, and this is 9 pi 18ths. Then we take a look at how far we've traveled. So in order for us to get to this angle, I've traveled a full cycle, 36 pi 18ths. Then I've traveled a quarter cycle of 9 pi 18ths, and I've traveled 5 pi 18ths more. Okay, so we are at, and we do need to simplify. So we are at, what are we? I'm looking at 50. 50 pi 18ths. Divide by 2, divide by 2, we are at 25 pi ninths as our answer. We are positive. We ended up going towards the positive y's, so it is a positive angle. Draw the angle and then find the reference angle. So here we are going to go down for negative. Ends in a 5, so that means we're going to be here, almost at a full cycle, not quite. We are at quadrant 1. That means our reference angle here is, where are we? To a full cycle, 25 degrees to a full cycle. Next we have 7 pi thirds. Let's draw this out. Again, almost at a full cycle, almost even a little bit more than a full cycle. I'm looking at 7 pi thirds. So if we have 6 pi thirds, 6 divided by 3 is 2 pi. This is a full cycle. So that means we're a little bit past a full cycle. So full cycle here, a little bit more. We're still at quadrant 1, but our reference angle is pi thirds. Find the value of the trig function indicated. So this one here, it is giving you reciprocal functions. So that means if I'm giving secant, that means cosine of theta is the reciprocal of what is given to us, 4/5. And if I was to draw a right triangle, how do we know this is a right triangle? Because they are giving us one of the 6 trig ratios, sine, cosine, and tangent. Here's an angle. It doesn't matter where that angle is. Let's make this our eyeball. Cosine is so, ka, toa. That means adjacent is 4 and hypotenuse is 5. So 5, adjacent's 4. This is one of our Pythagorean triples. You can use the Pythagorean theorem. However, this is a no calculator portion. You should know your Pythagorean triple of 3, 4, 5. And if it's asking you for cosecant, we can first find sine of theta. Sine of theta is opposite over hypotenuse. This is our opposite. Here's our hypotenuse. Here's our adjacent. Opposite is 3, hypotenuse is 5. But that's not what they're asking us for. They're asking us for cosecant, which is the reciprocal of sine. So cosecant of theta is 5/3. Moving on to the next one. It says using radians, find the amplitude and period of each function, then graph. We are going to be asking you to graph something like that. Step number 1 is y is equal to 4 times sine. You need to factor out that 4. Again, the trick is you're going to multiply by the reciprocal. So if I see 4, I'm going to multiply this value by 1/4, gives me pi 12ths plus 2. Next, we want to show our amplitude, which is the absolute value here. We know this is sine, so here's our midline. Sine's going to be top and bottom. This is a positive function, so it's going to look something like this. 4 is our b value. We're going to use that to find our period. Period is found by 2 pi divided by b, which is 4. So my new period is going to be, simplify that, pi halves is my period. New period. Next, this is my start value, my phase shift. So a lot of times you'll see what's a phase shift. It's your start value, opposite of what you see. We're going to start at pi 12ths, and k is your midline. When I do this way, when I identify by pulling things out with arrows, there's 2 values that are not given in the equation that you need to find. These are your end value. End value is found by taking your start value, adding your period to it. I do need common denominators. So my end value is pi 12ths plus 6 pi 12ths. So my end value is at 7 pi 12ths. The next thing that is not given to you straight from the formula is your distance between jumps, or your distance between your x values. And your distance between x values is found by taking your period and multiplying it always by 1/4. This 1/4 doesn't change. So I get pi, 4 times 2 is 18. No, sorry, 4 times 2 is 8, not 18. Here's the thing. The last step that you want to do before you start graphing is you want to compare common denominators. And those common denominators are going to be between your start value, your end value, and your distance. And I'm going to write this fraction a little bit better for 7 pi 12ths so we can see what I'm going to be multiplying. Same thing with pi 12ths. So notice that we have a 12, and an 8. Not the same denominators, so we need to do common denominators. What is common between 12 and 8? 24. So I'm going to multiply top and bottom by 3 for my distance. I get 3 over 8 times 3 is 24. Here I'm going to multiply top and bottom by 2, so my end value is now 14 pi 24ths, and my start value is now 2 pi 24ths. We can always go back and simplify our fractions in our graphing, which we will have to do. But let's go ahead and graph this. I'm going to create a common sorry, that's not what I'm going to create. I'm going to create an x and a y axis here. And we're taking a look at our certain things. Starting value is now at 2 pi 24, so I technically don't need a negative portion of that graph, so let me redraw that. I should have looked at what I need before I drew my sketch. I am at negative, just kidding, I am at positive 2 pi 24ths. My ending is at 14 pi 24ths, and my distance is 3 pi. So 2 plus 3, 5. 6, 7, 8. 9, 10, 11. 12, 13, 14. This should be where we're at. We should have 5 values. This is your start. This is not an asymptote. This is just me showing you where you're starting. This is me showing you where you are ending. Your midline is at positive 2. So here's your positive 2. Again, not an asymptote. This is just your midline. Your amplitude is the distance you go up and the distance you go down. So you go down up 4 and down 4. So 1, 2, 3, 4. This is your maximum. The reason I'm doing 4 is because we had an amplitude of 4. 1, 2, 3, 4. This is your minimum. Then you're going to take a look at your function. We had a sine wave that was positive. That means we're going to be increasing starting from our midline. The characteristics of a sine wave is that it starts and ends on the midline. Its middle is also on the midline. Since we have a positive sign, its first middle of middle, the quarter, is going to go up, and then the second one is going to go down. When you connect, you have to have a smooth curve. If it looks like you have sharp V's, credit will be removed because that is not what the function looks like. We're going to extend out. You need to have arrows because this is a continuing function. Remember, every dotted line that we have here is a guiding dotted line. It's not an asymptote. Nothing is an asymptote with sine and cosine. All right, let's do a cosine now. I'm not going to write here because it's going to get confusing, so I'm just going to write out on a separate sheet of paper what we have. For a cosine, this is question number 6. Y is equal to 1/2 times cosine of 3 theta plus pi halves plus, just kidding, that's a -1. Now again, if you don't like theta, if theta is just making you uncomfortable, you can always change theta into an x. If you are not caring about theta, then just keep it at 1. I'm going to put a 1 here as soon as my whiteout dries. Moving forward, let's go ahead and identify our information. We have an amplitude of 1/2. We have a cosine that is positive, so we are going to be increasing our function. We need to factor out our 3. And again, the trick here is multiply by the reciprocal. The reciprocal of 3 is 1/3, so I'm going to be multiplying by 1/3. 3 times 2 is 6. And then again, I had a -1. Then I'm waiting for the whiteout to dry. Next, we have our B value. Our B value is 3. We have a start value. Our phase shift is going to be at -pi6. B is used for your period. 2 pi divided by B is your period. So these are the values that we have. This is your amplitude. So 1/2 is your A. And then, again, things that are not provided by, oh, and I forgot our midline. This is your K value. Things that are not provided by the equation are going to be your start and end, your end values, and your distance. I'm trying to talk a little bit faster so this video is not too long, but I'm making mistakes in my speech, so I apologize for that. All right, our end is going to be our period, our new period, plus our start, which is a -pi6. Common denominators are needed. I'm going to multiply top and bottom by 2. So that means I have 4pi6 minus pi6. So my ending is going to be at 3pi6. Yes, I get to simplify that, but I'm going to wait to simplify that to see if I need common denominators at the end. Next, I need my distance. Distance I have is my period of 2 pi thirds times 1/4. It's always 1/4. 2 pi twelfths. And if you notice, I have a start here at -pi6. 3 pi 6, I could have simplified, I didn't. And here I have a 2 pi twelfths. I'm going to simplify this one because if you notice, if I simplify this to pi 6, these 3 values are common denominators now. When I'm done graphing all together, we can always go back and simplify our x values, which simplifying is required. We don't want to leave things like 3 pi 6, but when we're graphing, we want things in common denominators. It makes life easier for us. Okay, what's my start? -pi6. My end is at 3 pi 6, so I do need a little bit of my x-axis. So here is my, let me change to pencil. I always graph in pencil, never in pen. So we have here, where am I? -pi6. Here we have 3 pi 6, and my distance is 1 pi 6. So 1 pi 6, here I'm at 0. Travel another pi 6. Travel another pi 6. And I should have 1, 2, 3, 4, 5 values for my graphing. Next, we want to do our midline, which is at -1. And now we want to be careful with the midline and the amplitude. I do have a midline at -1, but my amplitude is 1/2. So I'm going to extend out. I'm kind of going to cheat a little bit. I'm going to extend out. I'm going to make this my -1 for my midline. And for my midline, I'm going to go up 1/2. This is my maximum. And then I'm going to go down 1/2. This is my minimum. Make sure to identify that. Now, it's not going to be the end of the world if you end up doing 1 and 1/2. But you technically want to do -3/2 and -1/2. Fractions are better than decimals. For sure, no decimals. Don't do decimals. Okay, here's our start value. Here's our end value. Again, we will go back and simplify those on the other graph as well. And what kind of function do we have? We have a cosine that's positive. Cosine positive means we have an increasing function that starts on our maximum. Our middle goes down to our minimum, and then our quarters, our middles of middles, are on the midline. You want to curve like a soup bowl. Curve down. You don't want to go past the maximum. So you can't go above this max line. You have to curve down so the wave can continue. Now let's go and simplify. Nothing needs to be simplified. Only this 3 pi 6. 3 goes into 3 once. 3 goes into 6 twice. This ends up being a pi half. Now I do want to take a moment and go back to the other example if I can. Let me see if I can find it real quick. Probably not, because that would be convenient. Oh, there it is. So this is our question number 5. Notice that here I didn't simplify. I am going to go back and simplify. This is pi 12ths. This can simplify. This is pi thirds. No, and this cannot simplify because that's 5 times 5 is 25, 7 times 2 is 14. So only a couple here were simplified. Make sure to simplify your x values. All right, moving forward. Find the missing side lengths. Leave your answers. This is where I was asking you to recall your memorized values, your formulas, or your patterns for your right triangles. This is from Integrated Math 2. The idea behind this is you are going to, for me personally, I rename my triangles. So I go in and I'm going to actually scribble out this N and this M. And you don't have to do that if you don't want to. I'm just going to ignore them because what I do is you can keep the N and the M. It's not going to be worth. So I'm going to find my pattern. This typically is X. This typically, here's 45 degrees, is X. And this typically is going to be your pattern of X times the square root of 2. Okay, you have to have your patterns memorized. When you do that, you can then identify your X. Well, your X here is 4. Your X here is going to be 4. Technically, this was N. And then since X and X are 4, this is going to be 4 square root of 2, which technically is your M. Going in here for your 30s, again, I'm going to label this is X. This is 2x, and this is x times root 3. And then I'm going to take a look. So x is 5. That means this is 5 root 3. And this right here is 2 times 5, 2 times your x value, which is 10. Which means n is 5 root 3. M is 10. Here again, 60 degrees. I usually find my 30 degrees. That's my x. These are patterns you have to have memorized. This is 2x, and this is x root 3. Again, these y's, these x's that they give you, these m's and n's, I am okay if you ignore them and then create your own like this. This is what I do. This is what I prefer. Which means 2 is x. That means that we have 2 root 3 as technically your y. And then 2 times x is 2 times 2. So we have 4 as technically your. Again, the x that they give you and the x that I'm writing are not the same thing. I am using x as a pattern for our triangles. If you recall from Integrated Math 2 and our lesson, when we have our 45, 45, 90 triangle, our pattern is x, x, x root 2. If we have our 30, 60, 90 triangle, we have x, 2x, here's 60 degrees. We have x root 3. And so this is the pattern that I'm using for solving. I take a side, I set it equal to whatever they give it to me, and I solve for my x, not the x that they gave me. Okay, moving on. Last portion of this for the non-calculator is to have your writing the equations of the sine and cosine. I'm going to do one of each. You should be able to write an equation for cosine and for sine. It says, examine the graph below and determine the amplitude phase shift, vertical shift of each using cosine as the parent function. Cosine starts and stops on either the minimum or the maximum, so I'm going to extend out. Notice that we have a max of 5 and a minimum of 5. that means that my midline is 0. Now your midline is y equals 0. That means that's your k value. Next, we want to find the start and the end of our cosine since they're asking of cosine. I'm going to choose a positive cosine, so I'm going to go back, curve up. If this is our start at pi fourths, I keep looking, here's pi, so that means here's pi fourths, pi halves, which is 2 pi fourths, 3 pi fourths, 4 pi fourths, this should be at 5 pi fourths. We need to calculate the period, which is the distance from your start and your end. Well, if we started at pi fourths and we ended at 5 pi fourths, our period is 4 pi fourths or just pi. This is our period. Next, we want to calculate our b value. To calculate for b, you're going to set 2 pi divided by b is equal to the period that you calculated. You can use 4 pi fourths or you can just use pi, which is what I'm going to do. Multiply both sides by b. That just shifts b to the right-hand side. We get 2 pi is equal to pi times b. Divide by pi, divide by pi. B is then equal to 2. And you are ready with all of that information to write your equation. I'm going to do this off to the other side on a separate sheet of paper. The function that we have is cosine. Y equals a times cosine of b times x minus h plus k. We want to take a look and see if the function we have is an increasing positive function or if it's a negative decreasing function. Because we are starting on our maximum, this is a positive cosine that we have. So when we have a equation, we're going to write a plus for positive. Next, we're talking about our amplitude. Our amplitude is the distance above or the distance below our midline. Our midline is at 0. I'm jumping up 5, so I have a 5 for A. We solved for B. B was 2. Opposite of what you see is your phase shift, your start value, which mine was pi fourths. So I'm writing a negative pi fourths because it's opposite of what you see. Our midline was 0. Distribute that 2. So we have 5. Just kidding. This is y. Y equals 5 cosine of 2x. We're not doing anything reciprocal. I'm just multiplying 2 times pi, which is 2 pi fourths. I'm going to remove that 0. It's unnecessary. It's not needed. And one last time to solve or simplify into a pi halves. This is one of the possible equations for that cosine. It is not the only possibility. There could be another one if you decided to do a negative cosine. I'm going to shift down to number 3. I'll leave number 2 for you to complete. This one is asking you for a sine. Sine is, let's go ahead and first identify your maximum and your minimum. They are being kind and giving you the midline. And if we do below the midline, we have our amplitude of 2. Midline is 1, 2, 3. Then we want to take a look at the characteristics of a sine wave. A sine wave starts and stops on the midline. The middle of it is also on the midline. So that means I'm going to have to extend this either forward or backwards. I'm going to extend it backwards just because I already have stuff written here. And if I was to continue my sine wave here, what would my values be? I need a start, a middle, and a stop on the midline for a cosine wave. So here is, I think I said a cosine. I meant a sine. A sine wave starts, stops, and has its middle on the midline for a sine wave, not a cosine, a sine. So if I was to continue, here we have, let's see what the distance is between each jump. Here's 3, here's 9, here's 2, and I'm trying to figure out, denominator is 2. So if I was to convert this, this would be 12 pi halves. This would be 6 pi halves. So it looks like each jump like this is 3. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is before. So 3 would be 0. So here I'm at negative 3 pi halves. And again, how did I calculate that? I did common denominators. I noticed that my denominator was 2, 2, 2, 2. Then I converted 6 pi into 12 pi halves. I converted 3 pi into 6 pi halves. That means that if I was to go backwards 3 jumps, I would be at negative 3 pi halves. Let's start our equation. Separate this out. The one thing I did not do yet is solve for b. So this is question number 3. Let's solve for b first. We have to calculate the distance between my start and my end. So if I'm at 9 and I add 3, that means I am at 9, 10, 11, 12. I'm at 12 pi halves, which means my period is at 12 pi halves. This is my period. And again, it's your call if you want to leave it at 12 pi halves for your period or you want to simplify it to 6 pi. I'm going to multiply b both sides, so we get 2 pi is equal to 6 pi times b. Divide by 6 pi, divide by 6 pi. Pi's go away. B is then equal to 1/3. Now that we have solved for b, we are ready to write the equation. We are writing it for a sine wave. Y equals a times sine of b of x minus h plus k. We have a sine wave that is starting on the midline. We are going up. That means we are increasing. That means we have a positive sine wave. Our amplitude was, how far up did we go? 2. And how far down did we go? 2. Our b value was 1/3. Opposite of what we see start value, our start value was a negative 3 pi halves. So I'm going to write a positive 3 pi halves, opposite of what we see. Our midline was at 3, so I'm adding 3. Again, make sure that you distribute that 1/3. This is not an opposite of what you see. This is not a reciprocal. This is multiplying. 1/3 times x is 1/3 x. You can also write that as x over 3. And then we are multiplying. We get 3 pi 6 plus 3. I will rewrite that. That is a little messy, and I'm going to shift my paper up. Y equals 2 times sine of x over 3, which is 1/3 x, plus 3 divided by 6, we get pi halves, plus 3. Here is one of the possible equations you can have for that function on question number 3. All right, beautiful people, it's been a little while. I'm going to cut that video here, and then on the next video, I will go through the calculator portion. Thank you for watching. Bye.